right, it's a pleasure to be with everyone today to talk about how we accelerate Mojaloop on TigerBeetle. So TigerBeetle is a financial transactions database designed to be 1,000 times faster than existing databases. TigerBeetle is built to power instant payments. So we believe that instant payments are where things are going, instant payments are the future. I think probably most people are already bought in on that idea here as well. But it pays to kind of look around us and see what are instant payments doing around the world. The world is becoming 1,000 times more transactional. We see it especially in UPI and PIX. So UPI 2017 did 4 million transactions in the month of, oh, someone's drawing, 4 million transactions in the month of February 2017. In 2 years later, just in 2019, it's doing 100 times that load, going from 4 million to 674 million. And today in January, almost 17 billion transactions were processed in January 2025. So it's got this 100x times in 2 years, and then in a few more years later, another 100x increase. So countries who want to do real-time payments, countries that adopt Mojaloop need ways to handle this sort of scale. When you go to instant real-time payments, the volumes typically go down, but the number of transactions goes higher. So how do we deal with this sort of load? And so that's why I'm here today. I'm here because 5 years ago, TigerBeetle was born as part of some of the work to do with the performance of Mojaloop. And our founder Joran saw that instant payments are the future. We realized that to do instant payments without being crushed by scale, we needed new technology. We needed new ways to process these transactions. So it's a pleasure 5 years later to come home to Mojaloop, to come home to the birthplace of TigerBeetle, and to share with you the progress we're making in putting Mojaloop, the current production version of Mojaloop, to run it on top of TigerBeetle for the clearing ledger. So what I want to do is show you just a little bit of a before and after picture of the progress that we've made so far. So what I did is I test Mojaloop with a certain specific set of hardware, and I generated a trace file. So a trace file is just a log of entries. We throw in as many transactions as we can into the switch, and we count, okay, every half a second, how many transactions completed, and what was the maximum latency? What was the slowest possible transaction? Because that's a really good measure of throughput, so how many transactions go through the system, and then like what's the worst possible performance that a user, an end user is going to see. So we have a log file. Here we go. We did it. So you can see on the left we have the before picture, on the right we have the after picture, and it's kind of hard to see, but there are more transactions on the right hand side. So cool, thank you very much. I'm just joking. We've got something better to show you. So I took this to the team. I said, what's a good way to visualize performance? You don't really have to look at it, Sam. It's not what's the best way to visualize performance? I took this to the team and we thought, why don't we have a race? So I'm here to announce to you TigerBeetle's latest project called Racer. Oh, access the microphone. No, thank you. Racer. Now, I don't know if we have audio, but so what we do here is we can race two database performance traces along side by side. Oh, there we go. Cool. So on the left, we have Mojaloop. I might turn that down slightly. Can you turn it down a touch, please? Cool, thank you. We've got Mojaloop running on MySQL. This is the V17 version of Mojaloop, powered by, on the switch, powered by MySQL. I'm just going to turn that down a little bit more. Cool. Maybe that's better. And then on the right-hand side, we've got Mojaloop running on top of TigerBeetle. So this is a performance preview. This is the work that I've been doing so far on how to get TigerBeetle into Mojaloop. So let's race. Are you guys ready to have a race? Cool. Cool. So what we're going to do is we're going to give MySQL just to give it the benefit of the doubt, just a little bit of a head start. So here's the starting line here, and I'm just going to hit start. 3, 2, 1, Off we go. Cool. So what you can see down the bottom left is the trace file. So this is the file I showed you earlier. We put it into the tracer and you can see the transactions coming through the system. This is the trace file I recorded from a few days ago. You can see 70 to 80 transactions per second. So this is the average performance I'm getting on Mojaloop using the MySQL database. And then the final one is the latency that I was talking about. So this is the maximum latency that a transfer takes. And this is on the order of 4 to 9 seconds on average, absolute worst. So there are transactions that are coming through faster, but this is the worst. And just a quick note about what are we actually measuring? What is a transaction per second? In this instance, we're talking about Mojaloop transactions per second. So there's a transaction, there's an instruction going from the payer DFSP to the switch. The switch does a bit of work and then forwards it to the receiving DFSP, the payee DFSP. And then that process happens in reverse. So that's one transaction. So this is like full end-to-end payment happening. So maybe we'll just let MySQL keep running a little bit. And I will just talk to you about what's actually going on here. Can you guys still see the progress bar up the top? Yeah, MySQL 70 to 100 TPS, cool. So in all of our benchmarking, this was kind of the number that we ended up at, was around 70 to 80 transactions per second. And this is on quite good hardware. This is running NVMe storage. This is running on bare metal instances in the cloud. And we can keep on throwing more resources. We can keep on spending more and more money, but we're not going to get any more performance out of the system. And that's because what we're doing here is performing financial transactions. We're performing debit credits. And when you use existing database technology to perform debit credit transactions, you have to do this thing called a row lock, a SQL row lock. And in highly contentious payloads, such as country level payment switches, like we're talking about here, these row locks mean that all the transactions have to line up one after the other in order to be processed. It's kind of like merging all the traffic from 5 lanes all down into one. But this just doesn't work. You're fundamentally constrained by this limit. So at TigerBeetle, we thought about this, and we thought, what if there's a different way? What if instead of having these people in the cars here, we put them all into a bullet train? And so what we do in TigerBeetle is we pack all these little, imagine each of these beetles is a transaction. We pack 8,000 in one train and we shoot it across the network. So we're still constrained by the same limits, but we find it's like a way around those limits to break through the fundamental limit. And that means that with TigerBeetle, we can go, instead of being constrained by these SQL row locks, we're now able to do 100 to 400,000 transactions per second. Why don't we just check back in on MySQL? Let's see where we're at. Okay, so I can't even see that anymore with the Zoom thing there, but I think he's about halfway through. This is a 10-lap course all up, and I think he's about 5 laps in, or maybe just under. So should we start TigerBeetle? Do you think we've given MySQL too much of a head start? Yeah? Do you think TigerBeetle will be able to catch up? All right, let's see how we go. Okay. Ready, set, and go. And we're off. And there's the overtake. So you can see transactions per second for this run is around about 1,000. Latency is still high. Latency is still exactly the same. And this is because of all the messaging. There we go, finished. TigerBeetle wins. All right. Did you even see that happen though? That happened so fast. Why don't we go to the replay? Here we go, instant replay. TigerBeetle's off. So like I said, it's a 10-lap course. And here we go, coming up on the overtake. Slowing down time. And I will note that this is a shark. There we go, overtaken. The shark was overtaken by the beetle. All right. And now we can go to the results. So for this run, TigerBeetle with this payload is 27 times faster than Mojaloop on MySQL. It took Mojaloop on MySQL an extra 10.5 minutes to do what Mojaloop on TigerBeetle was able to do in just 24 seconds. And high five, but we have a clear winner. There we go. So, okay. In summary, we are delighted to be part of the growing and thriving Mojaloop community. We're stoked that we can be back. We have the opportunity to come back home as TigerBeetle to the birthplace, to come back home to Mojaloop and have the opportunity to contribute back. We're convinced that real-time payments are the future. Investing in real-time, investing in the future means investing in database technology to power this future. So thank you for your time and your attention as we continue talking about real-time payments. And I will, with that, I'll hand over to Michael, or unless there's questions. Yeah. Thank you. Oh, yes. Yeah, we'll do it on the mic so that people on Zoom can hear.
Hi, my name is Hercules Fishman. I'm the
Hello.
CTO of SGA Global. Do you have MySQL to your database? Is there an automatic way, or
There's no automatic way yet. What we focus on is working from the chart of accounts. So going back to like first accounting principles, and this is what we're working on at the moment, and Michael will be sharing on. Basically, there's people who have existing ledgers they've implemented on top of MySQL, such as us here in Mojaloop. And what we find is those accounting principles map directly onto Mojaloop's principles. Oh, sorry, onto TigerBeetle's principles.
Right. Okay. Thanks.
Cool. James.
But one thing I would point out is that as with every Mojaloop major version increment, when we make a new release, we always release tools that will allow a smooth and seamless migration from the previous version to the new version. So
Yeah.
At some point, those tools will be made to transfer or archive whatever data might be necessary from the old ledgers into the new.
Yeah, certainly. Yeah.
Yeah, I mean, one of the things we've always said is that where we are making these breaking changes, we will always provide existing users with ways of migrating onto the new system. It's not always easy, as you know, particularly where people have got large-scale data storage already committed. But we are 100% sure that we have to make sure that people can switch from existing databases to TigerBeetle if required. Oh, sorry, when required was what I meant to say.
I just had one other question, Lewis, about
Yeah.
the test rig that you used there.
Mm.
That pretty astonishing performance, 2000 TPS, that was achieved on pretty minimal hardware, right? I mean, I know we saw Mojaloop doing 100 TPS there. So on a platform where Mojaloop's hitting 100 TPS, that's kind of a minimal set of hardware, right?
Yeah, it's about $250 a month.
$250 a month.
Yeah, like 3 or 4 head snare instances. So TigerBeetle here was doing full replication. So we're running 3 nodes, whereas MySQL was just like one.
Yeah.
Node. Yeah.
Understood. Yeah. Thanks.
Any other questions?
Oh, so that means that in a production grade deployment with TigerBeetle, the 100K TPS that you put up on the screen first, that seems really pretty easily achievable, right?
So yeah, this is where the terms get a little confusing, but TPS in that sense is like how many individual TigerBeetle transfers you can do. The way that we've currently designed our chart of accounts is around about, there's always an amplification between logical transfer per second, like a Mojaloop logical transfer per second, and then the physical, what actually ends up hitting the disk.
The movements.
So it's around about 4 to 1. With what we're seeing, it's generally like 2 to 10 X.
Yeah.
So you can kind of divide that number, but we're a long way, like the batch utilization is way down. So there's a lot more stuff to do first.
Yeah, understood. Thank you. It was amazing, and I really loved the game demo.
Thank you. Yeah.
Thank you.
The team worked very hard.
Yeah,
They're pretty
thanks
cool.
to everyone that did that. That was really astonishing. Thank you.
John, you had a
Thanks.
question? Oh, okay. Right.
Cool.
Anyone
Sam,
else?
sorry, Sam.
Thank you, Liz. Great presentation as usual. So I'm thinking you touched on this, but before we hit, let's say, the huge numbers like 100,000, I think there will be other bottlenecks like gateways, firewalls, things like that, and even load balancers. But even before we talk about such numbers for Mojaloop, maybe that's somewhere in the future. But let's say even for 1,000 to 5,000 transfers per second, schemes that want to do in those numbers, can we extrapolate based on your observations any resource benefits, like, for example, in terms of servers and like compute time? I think that might be the immediate benefit more than increasing the upper limit. On that. Can you touch on that?
Yeah, of course. I mean, it's quite early to say at this stage. But yeah, definitely, you know, I was doing some other work around improving the Kafka batching. And when I did that, what I could see is also you could get a much higher TPS with only running like one central ledger, one ML API adapter. So you can get that sort of like, so you're using less resources to do less, using less to do more. But yeah, that's going to come down to this, you know, it's like one of the tricky things is because MySQL has been the bottleneck, you don't see, there's like there's an analogy somewhere, I can't remember who uses it, but it's like the high pole in the tent. So you see that one, you can't see the other pole. So you pull the big pole out, and now you've got 3 or 4 other ones that you then need to go to. So Kafka's like number 2 on the hit list. But you know, there'll be more as we kind of work our way down. Yeah, I'm not sure. Cool. Awesome. All right. Well, I think then I will hand over to my esteemed colleague, Professor Dr. Michael Richards.
So I'm going to start with a little quiz. I kind of hope we'd had more competitors, but never mind. If you've got a finance or accounting background, put your hand up. Finance or accounting? Nobody's got a finance or accounting background. If you've got a technical background, put your hand up. Everybody's got a technical background except me, who hasn't got any background. Okay. So my question is, how well do accountants and engineers understand each other? And the answer is about that well. So this is about accounting for engineers. So one of the projects we're engaged on at the moment is improving the way in which Mojaloop reports what's going on so that it's comprehensible to someone with an accounting background. I think it's fair to say that when we started off the Mojaloop journey, we really looked at things pretty much from an engineering background, and we didn't spend too much time looking from an accounting background. We decided that really that needs to change. So this is an introductory presentation to work in progress, where we're hoping that people with an accounting background and people from an engineering background will be able to come together and develop a system which will work for everybody. So I'm going to start with some fundamental accounting principles. First of all, there's no such thing as negative money. Everything in the accounting system is positive. The only difference between positive and negative is that accounts can be either assets, in which case they're yours and you want them, or they're liabilities, in which case it's someone else's, and eventually you're going to have to pay them. And it follows from that, of course, that one person's asset is another person's liability. So one of the things you'll be seeing as I go through this presentation is that we're always going to be asking, what perspective are we looking from when we try and understand what an account is doing? Next one. Where money's Thank you. Where money's moving, you credit the source of the money and you debit the receiver of the money. That's the accounts that are from which the money is coming or to which the money is going. Debits rise on the left side and credits rise on the right side. So that means if I debit an asset account, I increase its value. If I credit a liability account, on the other hand, I increase its value. And crediting an asset account reduces its value. And finally, assets must equal liabilities at all times. So we must always, at any given point in the system, we must oh, my internet connection is unstable. That's interesting. Yeah. So at any point, we ought to be able to take the system, sum up all of the accounts, and they should equal 0. That is, the liabilities and the assets should always be the same amount as each other. Okay. No rounding, nope. Not even a little bit. So we need to account for the following things in the Mojaloop system. First of all, what we call good funds under management. Now, we've said a number of times, Mojaloop asks for participants to pre-fund their accounts. What that means is a participant, a bank or a mobile money system needs to convince this Mojaloop scheme that it really has the funds that it pretends in order to make the payments it's going to make. And when they say under management, that means that the scheme itself, the Mojaloop scheme, has got to have control of those funds. You can't have someone turning up and saying, look, here you are. I've got 10,000 Zambian kwacha in my bank account. There's the proof. And then, of course, I walk out of the office, go around the corner and draw it all out again. So it's got to be something which is being managed by the scheme so that we can guarantee that that liquidity cover will always be there. Second, we have funds which are reserved by the system. Now, one of the things that we want to do in the Mojaloop system in order to reduce cost and increase certainty is we don't want to move funds until we are completely confident that a payment is going to succeed. So when we get a request to execute a payment, when the Mojaloop system gets a request to execute a payment, the first thing it does is to reserve those funds against the debtor's account. And what that means is not that they've left the debtor's account, but that the debtor can no longer spend those funds. They are earmarked. Now, anyone here belong to a mobile money system? Yeah. Well, you know what happens in a mobile money system? If you say, I want to make a payment, the first thing that happens is the funds get reserved in your account. So they haven't gone, your balance is still the same as it was, but you can't spend those funds again. And those are funds which are reserved to cover expected obligations. Third, we've got obligations themselves. Obligations are completed payments which result in one party saying to the other, I owe you this amount. But they haven't yet been settled. Okay, so that's just an obligation. It's like a promise. It's a promise that's covered by money because of the good funds, but it is a promise. Then we have funds which are settled between participants. Now, in the Mojaloop world, we throw away we throw around the phrase settling, or the word settling. We don't settle. What we do is we send an instruction to some other system, an RTGS, an automated clearinghouse, whatever it might be, saying, please transfer funds from this account to that account. We know those funds are good because we made sure that we understood that in the first place, but we don't actually settle. We just send instructions. And I'm going to leave that last one out because I should have removed it before now. Okay. Now, what kind of accounts are we going to look at in the system? We're going to say that every participant, that is every bank, every mobile money system, every microfinance initiative, is going to have an account. And each of those accounts is going to have a number of sub-accounts. So they're going to be broken down into different accounts which are used for different purposes. And the sub-accounts are, first of all, the deposit account. Now that represents the first category of funds, the recording of good funds which the scheme is managing on behalf of its customers. It represents funds committed by the DFSP, and it's a liability because this doesn't belong to the Mojaloop scheme. It will have to repay it eventually. So if someone deposits funds and says, I want to do that, they are allowed to knock on the door of the Mojaloop scheme and say, I want those funds back, and the Mojaloop scheme has to provide them. Well, it has to provide the ones that are still available. Second, we've got unrestricted deposits. Now, I may not decide that I want to spend all of the funds in my account on funding Mojaloop transactions. I may decide to spend some of them on alcohol, excellent restaurant meals, other things that are worth having apart from Mojaloop payments. So the unrestricted deposits represent the portion of my deposit which I am proposing to use to fund payments in the system, and which I have not yet used. That's why they're called unrestricted. They're available for use. So that can be, I can get those back, funds from that account, via a withdrawal whenever I want it. This is my money. I've given it to the scheme temporarily, but the scheme has to provide it back again whenever I ask them. And it's an asset because we can use these funds to support payment activity. Next, we've got restricted funds. And these go back to the question of the second set of things that we need to account for. These are restricted because they are reserved to pay for transactions that are going through the system. When the transaction completes, they won't be restricted anymore. You'll see what happens. But essentially, they represent funds that we can't use anymore. If I knock on the door and say, please give me the funds back, and they are restricted funds, the system will say, sorry, you're not allowed. Those funds are already committed for use elsewhere. Then finally, we have two matching accounts, committed funds, which are either incoming, and that represents obligations that the DFSP has to another DFSP as a consequence of payments. So payments where it is the payer. The other one is the inverse of that. That represents payments where it is the creditor. Okay? So as payments go on in the system, as we see the TigerBeetle racing around the track, as payments complete, they will either be added, or there will either be an addition to the committed funds incoming if the DFSP is the payer, or there'll be additions to the incoming funds outgoing if the DFSP is the creditor. And what will happen eventually is that those funds will form the basis for the payment instructions that go out and make the settlement. Okay. Now we're going to go through the same step as we saw TigerBeetle going through. And we're just going to see what that means in terms of accounting. So first of all, when we prepare a payment, when a DFSP requests execution of a payment, we said funds are reserved. And that means funds are moved from the unrestricted funds account to the restricted funds account. This is an assumption that we got a payment of 100 Zambian kwacha. It's being moved from the payer DFSP, DFSP1's account, from restricted funds, sorry, from unrestricted funds to restricted funds. Okay, So those funds are now restricted. They can't be used for any other purpose. Next, when we complete a payment, now we create the obligations. And this gets a bit more complicated. So the first thing that happens is that the funds are moved from the restricted funds account, from the reservation account where they were before, to the incoming committed funds account. That means that I have now committed that payment. I am on the hook for those funds. Eventually, I will have to settle them. The receiver DFSP's outgoing funds, committed funds, is increased by the amount of the payment. So that says that's money that I am going to get, and I can be confident that I'm going to get it because of the pre-funding that went on before. And finally, the payer DFSP's deposit account is reduced by the amount of the payment. That's because those funds, though they haven't actually disappeared yet, are going to disappear. So we count them as already having disappeared because money that you've got to pay sometime is not available to you. You might as well account for it now. And then finally, we're going to look at what happens when we settle. So that settles by issuing, as we've said, requests to execute payments to some other system somewhere else. And in this case, the two committed funds account are reduced because those funds, the funds for that payment, are no longer committed. They are being settled. The unrestricted funds for the creditor institution, the payee, are increased because now it has that much more available funds. And the deposit account is also increased because now those are funds that DFSP2, the payee DFSP, could knock on the door and say, please give me that 100 Zambian kwacha. I know you've got it because you told me so. Okay. Now, as we say, this is an ongoing piece of work. We are talking to accounting professionals of whom I am, I won't say happy, but certainly not unhappy to say I am not one. And we're going to make sure, first of all, that we model this process in a way that an accountant will understand. And second, that we've converted this into instructions that an engineer will understand so that the circle is unbroken and we wind up with a Mojaloop which is not only fantastically efficient and high speed, as you've just seen, but will also bring a smile to the face and a glow to the heart of the most obnoxious accountant you can possibly imagine. That's all I have to say. Does anyone have any questions? No?
My question, I have a question around bilateral net.
Bilateral net settlement.
Yeah, are we still, is that still somewhere in the requirements? Or
I think it is.
Okay.
Let me give you an example. You saw this morning the DRPP system. Now, one of the things that happens in the DRPP system is we said jurisdictional systems are all settling in their home currency. It's only in the regional scheme that we're settling in different currencies with the currency converters. Now, what that means is that let's imagine a situation where we only have one currency converter. That currency converter will only ever settle with the jurisdictional scheme whose currency it's talking about. So let's imagine a situation where we are converting a payment from, I don't know what we're going to say, Kenyan shillings to Zambian kwacha. Right? That means that the DFSP who sends it owes the FXP in Kenyan shillings, and the FXP owes the DFSP who received it in Zambian kwacha. Now, they will only ever settle between each other. It will never be the case that the jurisdictional scheme settles with anyone else, unless, of course, there's more than one FXP in the scheme. But even then, it won't be a bilateral
as-
settlement
yeah.
because in each case, it will be a settlement between the jurisdictional scheme and that particular DFSP, because the DFSPs won't be paying each other. They will only ever be paying the jurisdictional scheme. So yes, is the answer. We do,
Then
we
you're
think,
saying
still
the
have
scheme is a
requirement.
participant. Then the scheme is a participant.
Then the scheme is,
Is a participant or not? Did I misunderstand that? Okay.
no. There are accounts which represent the
Yeah.
jurisdictional scheme.
Okay.
So
Thank you.
is everybody clear about the difference between multilateral settlement and bilateral settlement? Yes, no, no? Anyone?
I think I am, and then I'm not. So.
Okay. So bilateral settlement means if you, let's go back to here. Here we've got relationships between DFSP1 and DFSP2. Now, if you imagine a situation where we have 20 DFSPs, there'll be some between 1 and 2, some between 3 and 4, some between 1 and 4, some between et cetera, et cetera. Now, in a bilateral settlement, all of those individual relationships between two DFSPs will be accounted for separately. In a multilateral settlement, you just count up the net amount that each DFSP owes. If they're owed money, then they get that amount from the scheme. If they owe money, then they pay that amount to the scheme. They don't care who actually is going to get that money. And the scheme doesn't care, right? It just sends net amounts. So it's very much simpler and more efficient where you've got large numbers of participants in a scheme. On the other hand, there are particular circumstances like the one I've just described in the DRPP scheme, where actually there is no point in having a multilateral settlement because the lines are such that people only ever pay one person.
But is that then if one party is only ever paying another party, is it not then captured by the I'll talk to you later about it. Yeah.
So the most complicated way to do settlement is multilateral deferred net. That's where we're going to take every possible transaction that occurred and we're going to net everything out. Half of, or appropriately half of the DFSPs will be net payers and the other half will be net receivers. At the end, at the very bottom line, it will be X and X, always the same amount coming in and always the same amount going out. It's net zero. So while there is technically a settlement account or a system account, that account isn't real money. And at the end of every settlement, it will be zero. It started zero and it will be zero at the end. So if you figured out how to do that, what would happen if you only had two DFSPs in your multilateral settlement? Well, it would be bilateral. And so if you solve for multilateral, you're solving for bilateral. And that's deferred net, which means we can collect this stuff up during the day. And when we're done, we decide to run a settlement. Someone smashes the easy button and off it goes. They could, however, do that every single time a transaction flowed through the system, in which case it would be using the multilateral arrangement, but there's only two. One of them's a sender, one's a receiver. The exact amount is the same. And by the way, I'm going to settle it right at the moment at which I cleared it in gross, line by line, in real time. But I can use the same settlement tools because it's essentially a degeneration of multilateral net, and it's a degeneration of deferred, which is I don't defer it.
Those
there's
of you who were in
simplifications,
the
though,
previous session will notice that this is the mirror image of the why don't I solve the easy problem first and then see if that magically solves the hard problem.
Going to make it deliberately harder and do
Yes,
the
indeed.
multilateral one first, and the rest of them we
Absolutely.
believe will fall out.
And then we're going to spit on the other problem.
But there is one final thing with that too, which is that no complicated system that works, I should say every complicated system that works started off as a simple system that worked. There isn't a reciprocal condition in which you magically can derive a complex system from a simple one that didn't work. It's not going to suddenly get better by adding more code to it. So We have to get it right. The complicated
Indeed.
thing has to be right. And then we can add these other things on once we have that basically straightforward multilateral settlement. Complex as it is, these other things can fall out of it if it works.
I refer you to that well-known comment of the accountant Albert Einstein. Everything should be made as simple as possible, but not simpler. Talking of simple things, Simeon just popped his head round the door and gave me one of those T signs, which I think is his way of saying, if that thing were working, it would be at 0 now. Oh, it is at 0, but actually it's been at 0 the whole time. So thank you very much indeed. And I will look forward to spending many happy hours over this convening, talking about the minutiae of accounting practice. Thank you.